For example, if I had a question to say, what is the proportion of female students at the University of, or what is the sex? So now I'll measure the sex. Male, female. Now sex is not a number. That's an aspect. At the end of it, I should be able to say the University of Europe has more female students than male students. Okay? Or more male students than female students. This is still statistic. It's helping me to describe the population. But I'm not using numerical data to measure. I'm using qualitative data because it's just describing the qualitative aspects, characteristics of that population. For example, if you are going to a variable race, so you have whites, Indians, Chinese, Arabians, black, and the like. And you are asking the same question. Which proportion of these races is the highest in this population? Then you will be counting how many Indians, how many Africans, how many, and so on. So that's quantitative data. In many cases, we are required to describe aspects in terms of the quantitative nature. For example, when people talk about the gender issues, the issue of sex will be, sex of people will be a major issue. Male, female, male, female, male, female. Gender equality, who is accessing more resources and why. You can't run away from the qualitative nature. So some of the data you collect is qualitative in nature. When we are using qualitative data, of course, for you to be able to compute, you assign numbers. You will say male will be assigned 1, female 2. Just to help you when entering the computer will not talk about male, female, and count those into count numbers. So, but the numbers, don't forget, they are only referring to the quality. 2 does not mean it is twice as much as 1. It's just a label. Okay? So that's about quantitative data and the qualitative data. The other terminology which I want to talk about is that of the variable, which is an attribute which takes on different values in terms of values. For example, I use the example of height, weight. So, weight of students at the University of Europe, weight will be the variable. So, because they vary, the weights themselves are varying. That's why it is called a variable. So, any attribute which takes varying values is referred to as a variable. Age, height, income, sex will also be a variable. The different values. So when we talk about a variable, it is an attribute which takes different values. And also, the coming across these technologies, descriptive statistics, differential statistics. When you collect data and you summarize it in order to describe what you have just measured, we refer to that summarization as descriptive statistics. So the descriptive statistics takes the activity of summarizing, organizing, so that you are able to display and describe the particular population of the sample of interest. Whilst another branch of statistics is referred as the inferential statistics, and as the name implies, this statistics is for inferring from a sample to a population. You remember that we said that you as a scientist might be interested in describing a population. But because you cannot reach each and everybody in this population, you draw a sample. Now if you have drawn a sample and you take measurements of that sample, your interest is not to describe the sample. Your interest is still to describe the population. So there are statistics which you use for doing that. And that is referred to as inferential statistics. So in terms of steps, if you have collected the data from a sample, one would expect you to describe that sample. Okay? Using descriptive statistics. But after describing the sample, people expect you to infer what you have found in the sample to the population. And that inference will involve inferential statistics. Questions? Have you heard about this terminology? So this is just you'll get about some of this.
Qualitative, quantitative, population, descriptive, statistics.
So these are not new.
Not very new.
Very new. Not very new. Okay. Yeah, but for us to have common language, it's important so that when we talk about them, each one of us is on the same page. The other aspect that we want to talk about is about the measurements. Which is not a Greek as the other things we're talking about. this, you need to know what we are doing. The process of translating observations into numbers. Height. This person is very tall, much taller than that person. That's what you're observing. Now for us to talk confidently, we want to measure the height of this person and to measure the height of that other person. And then, based on the height, the measurements, you can now talk confidently and say, yes, this one is taller than this person, because this person is 1 meter and so many centimeters. But this one is less than 1 meter. Not less than 1 meter. Why not? If it's a kid, it can be less than 1 meter. Yeah. So, the process of measuring to assign those numbers to the heights is what is referred to as measurement. And based on the measurements which you take, you can now begin to interpret your observations. But for you to do so, as I said earlier on, you need to find a way of summarizing, find a way of organizing to be able to talk meaningfully about such aspects. Questions? Now we started very much later than when we should have started. I normally give you some 5 minutes break after 1 hour, but I don't know when the hour after. Maybe you can just go to break now. 5 minutes.
Year 1, eh?
Yeah.
We should stay on the first one. The first one.
Another aspect I want you to be acquainted with is that when you are taking measurements, there are a number of measuring scales that we normally use. Actually, there are 4 measurement scales which we normally use. We have a nominal scale, an ordinal scale, interval scale, and ratio scale, which we'll talk about. So when you go out to collect data, you need to understand how you are collecting that data, what type of scale. Because the scale you use for collecting data will influence the type of analysis you are going to do with that data. And I want you to mark that statement I would say. The type of scale influences the type of analysis. So, nominal scale is a very primitive scale which we use. It only involves placement of objects or observations into categories that are qualitatively different and not quantitatively different. Remember we talked about qualitative data and quantitative data. Now, if we're talking about the race, it's a data. Okay? Tribe. It's a data. Because you can have the Yao tribe, Chewa tribe, Longa tribe, Chumbuka, Stronga, Sena, and all those. Somebody who is from a Yao tribe is not the same as somebody who is from a Sena tribe. They vary in terms of their language. So it's a variable. But as I said earlier on, for you to analyze that data in a computer, for example, you have to assign numbers. So you will say Sena is 1, Yao 2, Chewa 3, Tumbuka 4, Tonga 5. But 5 does not mean it is 5 times more than 1. It's only a label telling you that 1 represents Sena, 5 represents Tonga. So when you analyze it, you cannot compute a mean. So if you get a mean of 2.5, what does 2.5 mean? It doesn't make sense. So you cannot mathematically manipulate those numbers. But you can do some statistics. For example, counts to know in a population who are in maturity age. If the question was, we want to know the tribes of the University of Lilongwe students. From those numbers, you can be able to say Chewas are in majority, Senas are minority. Because you've counted frequencies and you are able to say there are more Chewas in this group of people, or there are more Tumbukas in this group of people. So, nominal scale, the numbers are only used as labels to identify the categories of interest. Okay? Let's just see an example. 1 would be twice as much as or 2 will not be twice as much as 1, or 1 will not be half 2. It's just a label standing for either male or female. Okay? The second type of measuring scale is an ordinal scale. An ordinal scale is a scale which shows the order without necessarily indicating how far apart, but it just ordered 1, 2, 3, 4, like that. For example, if we had the 10 students in this class, and I administered an exam, and the first student got 98%, the second best 95%, the lowest got 89%. And I assigned the positions. Number 1, 2, 3, 4, 5, up to 10. Those positions that are assigned is a scale, which will be referred to as ordinal scale. Because let's say 1 got the 98, as I said, 2 got 95, 3 got 94. Three doesn't mean it's 3 times as much as 1. No, it's just showing the position. And I forgot to take a picture. Mark. You have 1 here. 1 being 98, 2 being 95, 3 being 94. The distance between 1 and 2 is not the same as the distance between 2 and 3. Okay? Or the difference between 1 and 2 is not the same as the difference between 2 and 3. Although, according to this ordinal scale, yeah, it's the same distance. 1, 1. Okay? Number 1, 2 minus 1 equals 1. 3 minus 1 equals 1. But in terms of the actual mass, it's not like that. 98 minus 95 equals 3. 94 or 95 minus 94 equals 1. So you will also have to be very careful in manipulating this type of scale. We should remember that the numbers are only representing order, but not the magnitude between those numbers. Okay? The only thing which is important is to know that 1 is greater than 2. 2 is greater than 3. According to the Maxwell, the original scale. And if 1 is greater than 2, and if 2 is greater than 3, then 1 must be greater than 3. That law must be maintained. Okay? Does that make sense?
Yeah.
So you need to know the rules which obtain on each of those measuring scales, so that when you are doing your analysis, you use the right type of analysis which will make sense. So in an ordinal scale, numbers mean order only and not the magnitude. Differences or ratios don't make anything. Does that make sense? As I was saying, 2 minus 1 equals 1. 3 minus 2 equals 1. But in the original scale of the actual mass, they are different. 98 minus 95, 95 minus 94 are very different. So there will be no basis to interpret the differences in terms of magnitude of this type of scale. Make sense? We'll be using some examples later on so that some of these things are more The other scale is referred to as an interval scale. And an interval scale is a scale where differences between numbers are equal. The difference between 2 and 1 is the same as the difference between 3 and 2, but they have no origin. They have no starting point. One good example of this type of scale is temperature. You know, you can measure temperature using Celsius and centigrade. You can also use the temperature using Fahrenheit. Yes. You can also use the measure temperature using Kelvin scale. The Fahrenheit scale has a 0. But it doesn't mean that let me start with the Celsius scale, because that's when we are mostly used here. We have 0 centigrade, 0 Celsius. But it doesn't mean that when it is 0, there is no heat. There is still heat. But somebody, for ease of measurement, allocated from his measuring scale, say at this point it's going to be 0. 0 degrees Celsius is equal to 32 degrees Fahrenheit, right? So it means that for the Fahrenheit scale you can go further down than the Celsius scale. You can continue to measure up to 0 Fahrenheit. And at 0 Fahrenheit doesn't mean that there is no heat. It's still there. Because the 0 level for Kelvin scale is minus 273 degrees Celsius. So you can keep going down. For the Celsius scale, the one who said that one said, at the melting point of water, we put 0. But there are certain liquids which will still remain liquids like that way. For example, mercury will still be a liquid. The melting scale of mercury, I think if I'm not mistaken, is that minus 273 degrees Celsius. Okay? So, but when you say 2 degrees Celsius, 3 degrees Celsius, 2 degrees Celsius there is a difference of 1 centigrade between 1 and 2. Okay? And 3 degrees Celsius, there is also a difference of 1 centigrade between 2 and 3. And these differences are equal. Okay? So there are equal differences of the attribute being measured, but there is no true 0 for it. Although people will use multiplications and divisions for such a scale, but the fact that there is no true 0 point, those multiplications and the divisions may not make sense. Okay? Addition is okay, subtraction is okay. But multiplications just done for convenience first. Look at them with a grain of salt. The most used scale, the most appropriate scale, the one you can do any type of computations without problems, is the ratio scale. The ratio scale is one which provides a true 0 point and has equal intervals. So differences between 1 and 2 are the same as differences between 2 and 3, are the same as differences between 9 and 10. Okay? And when you say 0, it is actually 0. For example, if you are measuring money, how much money do you have? If somebody says no money, that's a 0. You check in your pocket, you will not find anything, no oil. So you have a true 0 point. And because of those characteristics of equal intervals and having a true 0 point, divisions, multiplications make a lot of sense. Additions, subtractions make a lot of sense. So all types of statistics or statistical applications are appropriate in scientific scale. I missed one thing there. All types of statistical manipulations are appropriate in ratio scale. So things like weight, income, age, height, length are good examples of such scales. If you say that the weight is 0, it is 0, there is nothing. Age 0, is 0. Now, one thing which I want you to be careful is the second point there. When you are designing a measuring scale, something which you want to use to correct your data, where you are able to correct data in a ratio scale, correct it that way. Don't collect data in interval or ordinal scale or nominal scale where you can measure the ratio. For example, you want to measure incomes of people. It's very easy for you to transform that data into interval. You could correct the income in terms of who has more income, who has the least amount of income.
Why did you decide to take it? They can ask you to open the process. You should have seen me.
We have also Mr. Band.
You would say she has more income than him. He has more income than him. So you could translate that measurement into 1, 2, 3, right?
Yeah.
But if you collect that data in that form, you know that you have limited yourself because you have collected it in terms of audio instead of ratio. And then there are limitations of what you can do with audio data. If you just said, how much income do you have? 10,000, 9,500, 8,500. That data, you will do a lot of things. Okay? You can compute average income. You can compute maximum income. You can compute the lowest income. And you can do many things with that. But if you say highest income, lowest, medium, you can't do many things. That's what I'm talking about. Whether you can be able to collect data in ratio, collect it in ratio. Because even if later on you want to transform that data into audio, you will. The fact that you say 10,000, 9,000, 8,000, you can say 1, 2, 3, right? But if it is 1, 2, 3, you can't convert that data back to 10,000. If you don't know that it was 10,000, you will not be able to. So, watch that. It's a very important aspect. Take note of. Questions about measuring scales? Nominal scale, ordinal scale, interval scale, ratio. This data can be transformed into any of those we are talking about. But you cannot transform those into ratio. Okay?
So ratio scale is more than that.
That's the most powerful scale. Correct data in nominal scale where there is no way of correcting it in the other ways. Correct data in ordinal scale where there is no way of correcting it in the interval ratio. But if you are able to correct it in interval or in ratio space, you are better off correcting it in ratio or in an interval. Because you can transform it in any way you want. It's easy. Okay? Now, I started off when I was describing statistics with the statement which I said it's very difficult for you to make sense of data which have just been collected, not organized in any way. It's just a set of data. You have measured the heights of 1,000 people. So you have 5 foot, 3 inches, 4 feet, 3 inches, 6 feet, blah, 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 in a sheet. And so, tell me, are these people tall? Are they short? How do you describe them? It will be difficult for you to do. So one way of trying to make sense of the data which has been collected is first to organize it in some kind of order so that you can be able to describe it. So, organizing data is a fundamental step, is an important step in descriptive statistics. Two ways most commonly used to be arranging them in frequency distributions or in graphic representations. Just a second, I think I need to take a marker so that you can be demonstrating some of these things. Let's say we do a test in a class of 10 students, and one student got 95, the other one got 92, 90, 97, 99, 1, 2, 3, 6. So we need 94, 94, 94, 95, 98. Maybe since they only 10, you can be able to say how the highest is 98. 99, okay? Just a good, just to demonstrate how difficult it is. Let's assume we have the data points. How much confusion will we have? It will be so confusing. But one way of making this make sense is to make a diagram where you arrange these numbers. The highest is 99. 99, then there's 98, 97, 96, 95, 94, 93, 92. That's what I would say. Yeah, 92. So you can count how many 99s? There is one, yes? 98. We have, yes, 1, 97, 1, 96, there is nothing, 95, 2, yes, there's that one, So every time we find one, we say 1, and then the other one, put another one. 94, 2, so there's 1.
The one
Yeah.
straight.
Oh, there's also 90.
Then 93.
No, 93, 92, 2.
91.
right? If you do that, you can have made it proper there so that the demonstration makes sense. 96, 95, 94, 93, 92, 91, 90. You can add those times. 1, 0, 2, 2, 0, 2, 0, 1. Now we can begin to make sense. What was the most frequently occurring number? There are several frequently occurring numbers, 95, 94, 92. The least frequently occurring numbers?
96, 93, 91.
Okay. Even if you were to make a graph, you can be able to draw a graph. What was done there? If somebody says, what was the highest mark? 99. What was the lowest mark?
92.
So you have already started telling a lot of stories just by organizing the data like that. Make sense?
Yes.
What was done here is what we refer to as frequency distribution. Arrange the data from lowest, from 90 to highest, and then make targets. What we're doing here, we're targets. And then we can give you quite a lot of characteristics which you can describe in that data set. Questions? Makes sense? Okay. Does it make sense to you? Are we making sense? Yeah, I thought. But what we have done here can show us what is the highest, what is the lowest, what is the most frequently occurring, what is the least frequently occurring numbers by just doing those studies. So that's what we're talking about. If we have brought this in a graph, then they will show the shape of the distribution. And graphically, presentation is one way of organizing data. Just as I said, we brought this in a graph. I'm sure we know how to plot a graph. Yes. So, frequency distributions can easily be done by using graphical presentations. And these frequency distributions which I've just shown here, this done using the graphical presentations, because the graphical presentations actually in statistics have a lot of attributes which are used for describing populations skewed, or the graph is normal, you can easily do that. Use the graphical presentations. And there are a number of graphical presentations which we use in statistics. One of them is the frequency polygon. The other one, bar charts, histograms, pie charts. Yes, this can go. We had the 90, 91, 92, 93, 94, 95, 96. And I think we had one. After that, we had a 0. We had the true, and 2. We had the true, So that one we had the true as well, We had one,
95 was one, the one which was true was 92, 95.
93 was 0.
92, 94.
Oh yeah, 93 was 0.
93 was 0. Okay, so it is here. 94 was true,
Yeah.
95 was true. 1, 2,
Not sure.
2, true. 96 was 0. 1, 1, 1. So you can connect. No, it should be like that. If you draw a graph of that nature, which is just connecting the frequencies, is the frequency polygon. Okay? Because you have counted the frequencies and then you are just. But you could also have another graph which looks like this. I'm sure you have seen that. And it looks like that without connecting to